Good afternoon, everyone, and welcome. I'm glad you could join us today for our session. Today, our title is Designing Seamless Interfaces Moving Beyond MCU Limitations. This is going to be an inspiring discussion about approaches you can take back to your own workplace. My name is Gavin Moore. I'll be your moderator today, and I manage the Customer Engineering Support team, our team we are known as CES. My team will be hosting today's webinar. We're all based in Glasgow within the UK. Let me introduce you to them. Firstly, we have Graham, and he's our team leader. He's been with Bridgetek for over 15 years. He's been guiding customers and distributors through complex projects and helping them achieve successful outcomes. Secondly, we have our engineer, Aaron. He's more than 10 years at Bridgetek. He's worked closely again with customers to design and deliver fantastic user interfaces that make technology more intuitive and effective, and we'll see more of them later. Before we start, let me explain some general housekeeping. We will have a Q&A session at the end of the webinar, so please enter your questions in the Q&A chat box at any time, and we will answer as many as the time slot allows. Don't worry if we run out of time, we will respond by email. Feel free to contact us on our email at support.emea@brtchip.com if you have any questions after the webinar has ended. Please note we will also be recording this session so that your colleagues who may have missed this session can watch it at a later date. So no more for me to say, let's get started. I'll now hand over to Graham to kick off today's discussion.
Thanks, Gavin. Hi, everyone, and welcome to the webinar. In today's webinar, we're going to discuss the addition of a graphical touch interface to your product or device and how you can completely transform the user experience. When you're looking to update an existing product or design a new one, the microcontroller may not have the capabilities needed. Our embedded video engine devices offer a solution allowing you to create feature-rich graphical interfaces without requiring any graphics capabilities on the MCU itself. And even better, you can do so with minimal hardware and software changes to your design. First of all, a brief introduction of our company. At Bridgetek, we specialize in innovative bridging solutions. Founded in 2015, we are based in Singapore with offices around the world offering sales and technical support. Our products include microcontrollers and a range of embedded video engines, which we'll be talking about today. I'm going to hand you to Aaron, first of all, who's going to talk about our range of products.
Thank you, Graham. As Graham mentioned, the topic of today's webinar is our EVE embedded video engine graphics controllers, but we also have a series of MCU products available, along with development modules for both the EVE devices and our MCU products. We have our intelligent display panels. These are TFT displays that incorporate EVE and onboard MCUs. And finally, our TFT displays, which are ideal to partner with any EVE-based application. So first of all, yes, we have our embedded video engine ICs. These are high-performance graphics controllers and allow you to add graphical touch HMIs to any MCU with minimal design or redesign effort. We have our microcontroller units. These are optimized for high-speed protocol bridging and connectivity, and provide a wide range of interfaces, including USB. As Gavin mentioned, we have our development modules and boards available, and these are ready-to-use platforms for prototyping and integrating EVE and MCU ICs into your applications. As Gavin mentioned, this session is being recorded, so if you want to view this back later, and pause the video to have a better look at these overview slides, then you're more than welcome to. But here's a brief overview of the development modules and boards that we have available. We have our intelligent display panels. These are stylishly enclosed TFT displays which incorporate EVE ICs and onboard MCUs. Again, here's a comparison slide which covers the options available for our intelligent display panels. Finally, we have display panel accessories. These are TFT displays in ranges of sizes up to 15.6 inches and a variety of resolutions. Again, here is an overview slide that covers all of the available options and whether or not these panels have resistive or capacitive touch. I'm going to pass it back to Graham now.
Yeah, thanks, Aaron. So in today's webinar, we'll be discussing the challenges in adding a graphical user interface to your design. We'll explain how our Eve devices offer an effective solution. We'll highlight the key capabilities and benefits of Eve. We'll also cover some of the many applications of Eve, and we'll explain why offloading your graphics processing to Eve helps you create better user interfaces with fewer compromises. We'll also give you a short demonstration of this highly customized and eye-catching user interface, which is powered by Eve. First of all, why do we need a graphical touch interface? Well, in our office, we have a rather fancy coffee machine with a control panel using touch buttons and LED indicators, but no graphical display. Every week, someone asks how to set the water temperature, how to change the grinder settings, and many other questions. And of course, we get the user manual out. And so how do we start the automatic cleaning cycle? Well, apparently it's easy. We hold button A for 5 seconds, then we hold button A and B for 3 seconds, then we hold down button D for 5 seconds, and finally, whilst holding them, we release them and hold down button C for 3 seconds. Then the 4 lights turn green and the machine cleans itself. Okay, but what does it mean if they flash white and it doesn't start to clean? What's it waiting on? Well, to this day, I still don't know the answer to that one, so we just make a coffee and agree to clean it next week. We often see people using machines with questions like, what does that mean? What's it waiting on? Has it finished yet? What's it doing? Why isn't it doing anything? And more importantly, why didn't we get one with a touchscreen? And if we had, we would have a nice user interface where we can easily select the type of coffee we want, and we could tell the level of water and coffee beans, and we could start the cleaning cycle, and if it stops for some reason, we could determine what it's waiting on. Of course, it's not only coffee machines that this applies to. It applies to HVAC controls, industrial machines, medical devices, and many more. With an MCU in almost every electronic device that we use now, designers have taken the opportunity to add lots of innovative time-saving features. Unfortunately, unless the user interface evolves too, many of these are just too difficult to use. By combining the right user interface with the innovative features in your product, you can really make it stand out above the competition. You get more flexibility in the layout and how users interact with the product. You can guide users through the features of your product for an enhanced experience. And one thing that challenges designers, though, is how to add this type of interface and get the product to market in a good time. When we design a product, one of the most important decisions we make is selecting the MCU. The right combination of peripherals and I/O make the firmware development and product performance much easier when controlling motors, monitoring sensors, and communicating with other devices. We may require signal processing or a certain level of computational power. We may require a certain amount of memory, but not too much to keep costs under control. We select a pinout and a package size that suit the product form factor and our PCB design and manufacturing capabilities. We've spent a lot of time developing and fine-tuning code routines to process data and to make the product more responsive. And we probably have a brand of MCU which our developers are familiar with, both in terms of hardware design and software tools. Adding the graphical user interface brings a new set of requirements which go beyond the main product functionality. If we move to an MCU with graphics on board, we risk moving away from the most optimal and economic MCU. We risk extensive rework on the hardware, on the firmware routines, and learning new MCU tools. and even the learning curve in designing graphical user interfaces if our design team are inexperienced in this area. Instead of moving your design to a platform with graphics capability, why not add graphics, touch, and audio to your current one? And that's exactly why we created the embedded video engine here at Bridgetek. So next, Aaron is going to explain what Eve is and give you an overview of the product family.
Thank you, Graham. So when integrating Eve into your application, you would first start with your preferred MCU. We can then attach our embedded video engine to this MCU, which provides a graphics processing unit utilizing an object-oriented graphics approach for fast application development. We can communicate to the embedded video engine using I2C, SPI, or QSPI, quad SPI, depending on which version of Eve you're utilizing. This allows us to attach to your preferred MCU a video engine which provides video output to an LCD display based on the input object-oriented commands. This also provides a PWM backlight control for the backlight driver on your display, and integrates a touch interface, which utilizes registers in the embedded video engine to indicate when touches are processed on the screen. An audio output is available, which allows you to play inbuilt sounds or custom audio files. For the later generations of Eve, such as the BT81X and BT82X family, there is a QSPI interface incorporated, which allows you to add an attached flash IC, which can be used for offloading graphics assets, such as custom bitmaps or custom fonts. In the latest generation of the BT820, this supports an LVDS video input as well as SD card interface, allowing you again to offload any graphics assets that you need in your application or stream live video data directly to the display. So here's a flowchart of the evolution of Eve. It started in 2013 with the FT80X series, and through customer feedback and research into industry trends, we have slowly iterated the embedded video engine over the years to our latest BT820 embedded video engine. So starting with the FT800, this had a SPI or I2C interface and provided RGB 666 output to drive displays. Next is the BT88X series, and this adds a screen rotation feature as well as RGB 888 output to drive TFT displays. Next is the FT81X series. This ups the graphics memory included for storing graphics assets such as bitmaps or custom fonts for your application, and increases the supported resolution of displays to 800 by 600. Following that, we have the BT815 and 6 series. This adds support for the external flash, as well as Unicode strings, allowing you to integrate multiple language support into your application easily. Following that is the BT817 and 8 series. This adds non-square pixel support for round displays, as well as dedicated P-clock PLLs and 2x pixel mode. There is an automotive qualified AEC Q100 version of the BT817. This has an extended temperature range of -40 to 105 degrees Celsius. And finally, our latest BT820B version of Eve. This includes LVDS input and output and migrates to a frame buffer design. I'm going to pass it back to Graham now.
Thanks, Aaron. So now we're going to give you an overview of some of the key capabilities of Eve. With Eve, you can create vibrant and dynamic user interfaces at high resolutions. You can offload the graphics to Eve via simple object-oriented commands and let your MCU spend more time focusing on the application. There's no need to refresh the screen constantly, as Eve holds the current content until you send an update. In this example, we show a sensor application where you can easily display custom gauges and scrolling charts using just a few commands sent over SPI. As shown in this dynamic Formula 1 dashboard using the BT817A, you can create complex HMIs with bespoke controls using Eve's graphics acceleration with minimal MCU workload. We have highly customized gauges and indicators in many different styles with smooth animation shown here, including scaling, rotating, custom images, and alpha blending. In this pulse oximeter interface, we display data from a real sensor. We rotate the graphics and touch using a single command for portrait orientation. We use custom fonts, a custom art gauge, and real-time scrolling chart, as well as custom progress bar to guide users in positioning their finger on the sensor. In this smart home system, we use the FT800 to drive a circular display. The user can interact via a capacitive touchscreen and an additional rotary switch. We use custom icons to provide a stylish user interface. And we use it alongside Eve's built-in widgets such as toggle switches on different pages of the application. Customers expect an immersive smartphone-like user experience, and with Eve you can create this easily. Combining powerful graphics processing and effects with images, videos and fonts allows you to create stunning user interfaces with minimal resources. In this example, we showcase some of the image formats possible. Eve supports formats such as ARGB1555 with transparency, making it ideal for icons. In addition to the transparency within the image, we can change the color with a single command and even change the alpha level to make it transparent. We can scale images easily as shown here with just a couple of commands, with letting Eve do the calculation. Its powerful graphics engine allows us to blend images with shapes to round the corners and takes the hard work away from the MCU when rotating images. In this EV charger application, we showcase the BT817 driving a 7-inch display. We can provide multiple application pages to present data in different formats to the user. We can play videos direct from the Eve attached flash as shown here for advertising or user help guides. Back in the main screen, we can use a full screen background image in ASTC format, along with custom fonts, bespoke gauges, a scrolling chart with gradient background, and alpha commands to produce semi-transparent panels to group together the controls. In this medical application, we use the BT820's powerful graphics and frame buffer to render dynamic charts as well as animated icons and touch control. Extra large fonts in any style you require ensure good readability, and touch control with pop-up message boxes also helps make it intuitive and keep users informed. Adding multi-language capability is easy too, with custom fonts on all versions of Eve, and Unicode support on the BT81X and BT820, making it ideal for selling your product in an international marketplace. Adding touch control may seem challenging, but Eve makes it easy as well. Eve takes care of reading the touch coordinates, processing them, and informing your MCU on which item is being touched via a simple register read and optional interrupt. Eve also makes tasks such as screen calibration as simple as calling a command. Custom Touch allows you to support a wide range of capacitive touch controllers too. Assigning tag numbers to items on the screen allows you to detect touches such as the buttons shown here. And touch tracking is just as easy, allowing you to determine the position of the touch on a linear slider or even a rotary control, making it easy to produce these type of controls in your application. By combining an image with touch coordinates, we can create controls such as color pickers. You can use up to 5 simultaneous touches too on capacitive versions of Eve. And you can create your own custom user controls, such as this carousel, allowing users to pick different options. We use images as icons here, along with rotary tracking, to make the application much more intuitive. With Eve, you can enhance the user experience even further with sound effects and audio playback, ideal for acknowledging touch, for example. Creating, fine-tuning, and playing sounds on an MCU without glitches can be a time-consuming process. With Eve, you can play a wide range of ready-made sounds with just a couple of register writes. If you want to use your own sound effects too, that's perfectly easy too. Simply convert the sound effect or audio file using our Eve Asset Builder, load the data into Eve, and tell it to play the sound. In this short example, we use rotary tracking to create a click wheel to select from our range of built-in sounds. We can set the volume via a slider, and then with two simple register writes, we can tell Eve to play the selected sound. We can also play this audio file that we've converted using Eve Asset Builder, where we play music in the background with a dynamic gradient effect running. From a hardware perspective, adding Eve to your product is easy too. It only takes a small area on your PCB with features to simplify routing and minimal external components. The display settings make it ideal for a wide range of panels and form factors, including circular and bar-type displays. Rotate the graphics and touch via a simple command to use landscape panels in portrait orientation too. Our development modules provide rapid prototyping as well as faster time to market when used in your final product too. On the software side, integration is equally easy. Eve's object-oriented API is easily supported on any MCU and makes developing and maintaining your application simple. As your product evolves with different UI designs and screen resolutions, you can use the same user interface across different Eve family members easily. As an example, the MCU can send a 20-byte gradient command, and Eve will calculate a smooth color gradient between two coordinates with a selected start and end color. So talking of software development, Aaron is now going to give you a brief overview of the software tools that we have available.
Thank you, Graham. So yes, to aid in software development and application development, we have a suite of free software tools and examples that are available for use. The first of which is our Eve Screen Designer toolchain. Now, this is a full what you see is what you get editor, which will allow you to generate a full project application, including multiple pages and the logic between these pages. This can output full application code, which can be ported to your MCU of choice. The next toolchain we have is our Eve Screen Editor toolchain. Now, this is a screen emulator tool, which allows you to view the raw embedded video engine commands, which we call display list or coprocessor commands, in its window here. This allows you to see what commands exactly are required to generate a screen on Eve and can be utilized with USB to SPI converters to attach directly to development modules or your application module. The next tool we have is our Eve Asset Builder toolchain. This is used to generate any Eve readable assets, such as custom bitmaps or custom fonts that you may wish to use in your application, along with supporting the ability to flash the attached flash IC on the Eve generations that support these, and it can be used to compile custom touch firmware for capacitive touch controllers on the versions of Eve that supports this. Finally, we have our GitHub page, which includes a variety of software examples. The main two repositories are MSVC-based examples. These are Visual Studio-based examples, which you can use with USB to SPI converters to run applications on Eve, or you can port these to your desired MCU. The Other repository to take note of is our Eve MCU dev repository. This is a low-level HAL library, which can be utilized to develop applications and supports a variety of MCUs currently. Along with our free toolchains, we also offer comprehensive technical support. We have extensive hardware and software expertise with a global support network, and we aim to rapidly support you through your product development cycle. So we're going to cover now an Eve-based example. This is our data visualizer example. And the main idea behind this example was to show that it's easy to create attractive HMIs with Eve very quickly and efficiently. So we've just switched camera here. And as you can see, here is the data visualizer example. The first one here is running on our BT820 based 5th generation Eve on a 15.6-inch screen. The second one down here in the corner is running on our FT813 based Eve solution on a 5-inch screen. So the idea behind this example is that it is supported on all Eve generations, and it shows that you can scale this example as required through resolutions. So this is a 800 by 400 screen, and this is a 1920 by 1080 screen. So one of the main benefits of Eve that Graham has already mentioned is that it offloads all of the graphics processing from your MCU. So these screens, this data visualizer example, was generated by issuing SPI commands from your MCU to Eve. And this allows us to generate shapes using graphics primitives, such as circles or lines or rectangles on the screen, and offloads all the computation required to do that from your MCU. So one of the benefits, there you go. One of the benefits of Eve is that it allows you to add gradients across some of the widgets, as you can see here on the bar gauges and across the back of the line graph and on the circular gauges here. And this takes the computation of applying these gradients across these widgets away from your MCU, as these can be accomplished with relatively few Eve-based commands, and Eve crunches all the numbers and decides exactly what pixel values are required for each section of the screen. So the idea behind this application, this demo, was that it utilizes only Eve graphics primitives and items such as inbuilt fonts that come included with Eve. So there are no custom graphics in this, which, if you're anything like me, is a bonus, because I'm not too great at Photoshop. So coming up with different graphics assets for the application can be difficult for me at times. So the idea behind this was to create an attractive HMI display that doesn't use any custom graphics. And the benefit of this as well is, again, you can see it's scaled down to a smaller screen here. And that means we don't have to maintain multiple different sizes of the graphics assets we need to use in our application. So along with this attractive display, we have a few other features included in this demo. So one of them is the touch that Graham's mentioned earlier. And this menu item here has been tagged with a touch tag. And so when we press it, Eve updates a register. The MCU then can read this register and decide what item has been touched. So for example, we can change the sub-menu here based on the tag reported back by Eve. We also have the touch tracking and the arc gauge here for brightness on the screen. And one of the other benefits of Eve is that it will continuously render a screen based on the last display list that you have issued to the device. So for example, if you do not require any screen updates in your application, you can render a single display list, and Eve will continuously draw these items on the screen until you decide that you need to update the screen with some new information, and then you can issue some more commands over SPI or I2C if it is the FT800 to update the screen. So this allows you to offload all of the graphics processing required to drive your HMI application from your MCU, and it allows your MCU to concentrate on a variety of what may be more important or time-critical components of your overall application. So this example, we've decided to create these useful widgets which users may want to utilize in their application, such as these bar gauges and this simple line graph and these circular gauges. And these are available on our GitHub in the Eve MCU dev examples folder. And so these are all parameterized and turned into individual function calls, which we can utilize. So if we go back to the main screen here, you can see a screenshot of the application mid-run. And you can see that we have created some function calls here, such as the line plot, or the vertical bar gauge call, or the circular gauge, which you can take and use in your own applications if you desire. But the idea here is to show that it's quite easy to create custom widgets just using Eve graphics primitives, which you can then just drop straight into your application if these widgets align with what you're trying to do. So the next question is, how would we create such a widget based on the Eve primitives that we could use in our application? Well, we can use our Eve screen editor toolchain, for example, to emulate a screen. Here we have, for example, one of the bar gauges, and we can view the commands used to generate the bar gauge here and play around with these to get different looks. For example, if we move this vertex here, we can see how the bar gauge fills. Once we're happy with our prototype that we've created in Eve Screen Editor, we can potentially export this to a project. For example, we can pick an Eve MCU dev-based project here, and this will generate a project that will allow us to run this Eve code on a display. As you can see here, there's a main example file that includes all of the commands that we've prototyped in Eve Screen Editor. Now, if we want to take the bar gauge and create a standalone widget out of this, these are the commands that are relevant, as the other commands were for the background of the bar gauge and the main screen. So we can take these commands and place them into a function in our main application, as we have done here, such as the vertical bar gauge. And you can see we have parameterized this, so we can place this on the screen where desired with input X and Y's, as well as a height and width, and then the value we wish to display on the bar gauge, including also colors if we want to recolor the item. So in our application, we have called the vertical bar gauge 6 times and placed this on the screen. And you can see that some of them also have a gradient placed across them. And this will include a couple extra commands. But again, Eve offloads all of the intensive computational effort that would be normally required in an MCU-based solution to calculate where this gradient has to be on the bar gauge, what the fill level is, and exactly all the pixel values for these. So you can see that with Eve, we can create customizable and highly attractive widgets just using the inbuilt primitives. And these are relatively easy to do with a minimal number of commands. I'm going to pass it back to Graham now, and he's going to talk about some typical applications for the embedded video engine.
Thanks, Aaron. Yeah, so in terms of applications, almost every industry is beginning to, or is already adopting graphical touch displays, and Eve is ideal for applications such as medical devices, kiosks and digital signs, especially with our larger, higher resolution models. Instrumentation using stylish user interfaces like the one Aaron's just shown. Remote vehicle control, where with our BT820, you can even incorporate live video into your UI with touch controls overlaid. Vehicle dashboards, such as this Formula One dashboard shown here, where you can have a large number of dynamic gauges and controls being animated at the same time. Things like lobby entry systems, where you can combine live video from cameras with stylish user interfaces and directory systems. And things like coffee and vending machines, where you can enhance the user experience. And really almost any other application as well. So we're going to summarize some of the benefits for designers when you're integrating Eve. in comparison to an MCU with onboard graphics. When we think about the tasks involved in operating a graphical touch display, in terms of an MCU with onboard graphics, it would have to perform tasks such as generating the graphics themselves, calculating gradients, for example, and transforming images for rotation and scaling. It also requires to constantly refresh the screen and output data for the screen. And it also requires significant amounts of flash for asset storage for the kind of user interfaces that users have become accustomed to. You can offload all of these tasks onto Eve with our simple object-oriented commands and our directly attached storage. Touch also can be a burden on the MCU. The MCU must communicate with the touch panel and update and receive the coordinates for every touch that occurs and process those coordinates and then work out which item on the screen is being touched. With Eve, you can actually offload all of that onto Eve itself via the touch engine, as we showed in some of the earlier demos. Audio as well, it can be an issue for microcontrollers when they're performing other real-time tasks. To achieve glitch-free audio of a good quality can be very difficult and time-consuming, whereas with Eve, you can offload that task with a simple register write to play your sounds. And another big factor is managing the time between the main application and the graphics. All of these tasks above provide an additional workload for the microcontroller over and above its primary task. And by offloading all of these using Eve as a graphics accelerator, you can allow your application to focus primarily on the product function. So to summarize, you might be updating a product to add a graphical user interface, or considering the best solution for a new design, or perhaps your current UI solution isn't providing a good quality graphics and performance. So here are just some of the benefits of choosing Eve. You can avoid a major redesign effort with many revisions and trade-offs to add an eye-catching, feature-rich user interface. You can achieve faster time to market by offloading graphics, touch, and audio to Eve and using our tools to help you develop your UI quickly. From the hardware side, integration is equally easy with minimal external components and impact on the PCB. As your product line evolves, you can take advantage of the commonality and scalability across the Eve family, which Aaron mentioned, and the easy migration of your design if the host MCU changes. With Eve, you can focus on innovating and making your product stand out in the marketplace. So transforming the user experience doesn't need to be difficult. It's easy with Eve. To find out more about our range of products that we mentioned today, you can use this QR code to download our latest brochures. We're also interested in hearing about your Eve project ideas in our Eve challenge. You can access this form to submit using this QR code for a chance to win a full development kit with 15.6-inch display and BT820. And we're also running a customer survey where you can leave feedback on our products and services. You can use this QR code and complete our survey for a chance to win a Galaxy Watch. So thank you very much, and now it's your turn to test our knowledge with any questions that you have. So I'll hand you back to Gavin for the Q&A session.
Thank you, Graham. Thank you, Aaron. It's now time for the Q&A. Could you please type in any questions in the Q&A chat box? Whilst you're doing that, I'd like to let you know about our next webinar in the series, and it will be on the 20th of May. And we've got the same time slot as today, and the title is From Design to Device, Showcasing Eve Capabilities. Let me just check our Q&A. Okay, so no questions at the moment. So whilst we wait, I will get the ball rolling with a general ask question. What resolution would you recommend for a 7-inch display?
Hi, Gavin. Thanks for that question. So typically with 7-inch displays, it depends on the exact pixel density that you want on your display, but very common options are 1280 by 600 or 800 by 400. So again, it just depends on the pixel density that you wish to utilize in your application. But the Eve generations of chips, especially the BT81X and BT820 series, are perfectly suited for driving displays up to these sizes and can be utilized to provide attractive HMIs as well as the touch and audio capabilities on 7-inch displays.
Thank you, Aaron. Is there any restrictions in my MCU choice to use my product with Eve?
Yeah, so there are the main requirement is to have an SPI interface on the microcontroller, but you can really use Eve with any microcontroller, and even on other platforms such as FPGAs and embedded computers, which have an SPI master interface available. So you can use it with almost any MCU on the market.
Thank you. And one more is, would you recommend Eve for a medical application?
Yeah, so we would indeed, and we see many medical applications with Eve. For example, some of the demos behind Aaron here, we have a medical patient monitor here running on a 15.6-inch display with BT820. We also have the BT883, which is running the small pulse oximeter demo here on a 4.3-inch screen. And we also have our BT817A, which is automotive qualified and is also ideal for a whole range of medical instruments up to around 10.1-inch. So Eve is an ideal platform for medical displays, especially because you can offload the processing from the microcontroller in the product and allow Eve to take the weight of the graphics processing. You can also use our touchscreen with medical gloves as well, which is ideal for medical applications as well.
Okay, thank you, Graham. Okay, we have a question here. I have designed an Eve 3 Reverdi module into a new device. It was a late addition because we decided we needed admin access to feature changes on the device itself. However, I'm struggling to find electrical engineers or embedded system coders who are familiar with Eve and its programming tools. Is it easy to use C++ embedded coding skills to work with setting up an Eve? And is there a consideration of a more visual design program?
Yeah, thanks for your question. So yes, it's very easy to do that. We have a range of tools and libraries, and it would actually be great if you could join the webinar on the 20th of May, and we're going to give you a more in-depth overview of those tools. But we have a range of tools which Aaron mentioned, including graphical tools which can generate the UI all the way through to code-based examples. We actually have the Eve API published as a document, and we have layered code examples on GitHub, they're written in C language, but they're easily ported to any other platform as well, and in any other language such as C++. And because of Eve's object-oriented programming, it's quite easy to port these layered libraries into almost any tool chain and any platform. But we certainly also offer comprehensive technical support, both to yourself and your colleagues during the design process. So please do get in touch, and we'll be pleased to point you to the best library to get started with, and we'll help you out during your code development. Anybody else got any other questions? Okay, no more questions. So I just want to thank everybody for their attendance today, and thanks to our presenters, Graham and Aaron. And please join up and come to our next one. Thank you. Bye.